Now, I gave you 5 different ways to think about vectors, and as if that weren't enough, here I am giving you another one. This is essentially a 6th way, although you could sort of view it as an abstraction of the other ways. I want you to think of a vector also as a function. Okay, now this, when I first learned this concept, I was like, whoa, function and vector seem like 2 completely different things. Actually, in a weird way, they're the same. Okay, so function is a word which, if you've taken volume 1 of all the math, you will remember, is essentially a relationship between 2 sets, whereby every element of one of the sets I'm going to map to an element of the other set. All right, so let me draw a couple sets here. Each of these blobs is representing a set of things. And maybe over here we have all the different soft drinks. And this is the set of soft drinks. So down here we have Dr. Pepper, and we have Mountain Dew, and we have Coke, and we have Pepsi, and we have root beer, and we have Sprite, and we have, what else? Mellow Yellow. Do they still have that? I don't know. I don't even know how you spell mellow yellow. Anyway, we'll just say mellow there. And then let's say over here we have all the people, and we're going to say in our universe there's only 5 people, and they are Poe and Kylo and Finn and Hermione and Harry. Okay, and we're going to basically establish a function. And again, a function is like a mapping between these 2. And we're going to show which one has which drink as their favorite. So we're going to say, Poe really loves Dr. Pepper, and Kylo Ren is down with that too. And Finn loves Dr. Pepper too. Who doesn't? Harry's a little different. He prefers a Coke, and we'll say Hermione prefers a root beer. I don't know, right? Okay. So basically, every element of the domain is what this set is called, is mapped to an element of the codomain over here, right? So those are our special names for the 2 sets. And the function, we will say, a function f goes from the domain to the codomain. That just means the mappings go in that direction. Okay, so not a very hard concept, very, very fundamental to a lot of math. Okay, so what does it have to do with vectors? Well, if you think about it, let's take one of our interpretations of a vector, which was to say it is a thing of numbers 2, 7, 9, 6, 5, right? And we said we could index those by just numbers, 1, 2, 3, 4, 5. If we're doing it the R way, or if we're doing it the Python way, we're going to start with 0. Let's use the R way just for sanity's sake in this particular example. Really, if you think about this, this is nothing more, get this, than a function where the domain is 1, 2, 3, 4, 5. And the codomain has a bunch of numbers in it, 2, 3, 5, 6, 12, 7, and 9. And we're going to say that 1 goes to 2. That's because the vector at position 1, or at index 1, is element 2. 2 goes to 7, and 3 goes to 9, and 4 goes to 6, and 5 goes to 5, right? So this vector is essentially a bunch of mappings from index numbers to their corresponding elements, and therefore you can think of it as a function. And of course, it becomes even easier to think of if we have, y. And it is red, blue, green. These are my favorite colors. And the people it goes with are Dave and Filbert and Bessie and Jezebel, because now we've got a set of people which are Dave and Filbert and Bessie and Jezebel. Sorry, my diagram's so ugly. And over here we've got the set of all possible colors, which is red and purple and black and white and blue and green and plaid. And we're saying that Dave goes to red and Filbert goes to blue and Bessie also goes to blue and Jezebel goes to green, right? So once you see it in that light, you realize that a function and a vector, in a weird way, are actually kind of the same thing, and there will be times we need to use that. So vector and function, same thing. Weird.